everyone, my name is Anna-Lena. I am a PhD candidate at Carleton University, and I'm really looking forward to tell you a bit about how the social sciences can promote more equitable and just algorithmic system design. I have to clarify one thing right up front though. The visual style of this presentation has absolutely nothing to do with its content. After almost 4 long conference days with many sessions and presentations, I just thought it would be nice to look at some greenery. So here you go. But back to the topic at hand. The overarching goal of my work in general is to bring the fields of computer science and human-computer interaction into much closer conversation with the domain of the social sciences. Because as it stands, the computer sciences and social sciences are still often perceived as distinct standalone domains. What I mean by that is that, in my observation, the social sciences have a keen eye for the complex forces that shape our diverse experiences and excel in uncovering an issue's genesis by making sense of how the past has shaped the present. What is sometimes missing, though, is the practical application of this knowledge. It tends to stop there. Not always, of course, absolutely not, but just as a trend. Then on the other hand, we have computer science disciplines and human-computer interaction, which are very skilled at identifying existing issues and at proposing practical solutions. But they sometimes miss to unpack and to scrutinize a problem's history and evolution properly. To be very clear, this is not a criticism, it's not an accusation or allegation, it is just an observation. Because of course nobody can do everything, and we shouldn't expect that either. But what it does mean is that we do have a lot of domain-specific knowledge, while interdisciplinary socio-technical expertise is still a little scarce. So what I argue in this paper, and consequently in this talk, is that fostering interdisciplinary socio-technical knowledge and promoting a stronger connection between the social and computer sciences can support the design of algorithmic systems that result in more just outcomes and cultivate what I call affirmative algorithmic futures. Following philosopher Rosi Braidotti's work on affirmative ethics, Affirmative Algorithmic Futures describes futures in which we as a society have engaged with and learned from the damage that has been caused by the implementation of algorithmic technologies, from those who have suffered and those who have been excluded, and in which we have created new ways of living with algorithmic systems in more just and sustainable manners, striving first and foremost for doing no harm. It is a response to a toxic technological solutionism, and it is always conscious and critical of the world in which algorithms are put to work, of the systems of power they are embedded in, and of the impact that our relationships with algorithmic systems have on the planet. In the paper, I discuss in detail what kind of futures we currently tend to provoke when we introduce algorithmic systems in different contexts, and how this differs from the vision of affirmative algorithmic futures. And I invite you to have a look. But for the sake of time, I'll just say that the impact that algorithmic decision-making practices have on individuals' daily lives differ vastly by person and context. And while this can result in outcomes that are perceived as useful and convenient, there are also many moments in which the implementation of algorithmic systems can produce real harm. However, I argue that instances of algorithmic harm are not standalone occurrences, but they are related in the sense that they are symptoms of a broken-down system. My reasoning is informed by Ruha Benjamin's work that positions the glitch as a, quote, technological canary in the coal mine, end quote, and a form of evidence that signals towards underlying flaws of a corrupted system, as well as Louise Amour's work that recognizes moments in which algorithms appear to cross a threshold into madness as instances in which, quote, algorithms give accounts of themselves and of their mode of reasoning, end quote. What taking on this perspective allows us to do is to trace the underlying mechanisms that result in these discriminatory outcomes. And there are, in fact, 2 major dynamics at play that provoke the occurrence of algorithmic harm: the replication of an unjust past and the application of technological fixes to social problems. Again, in the paper I explain this in much more detail, as both are very complex phenomena, but for the sake of time I'll greatly condense it. The replication of the unjust past describes the processes by which unjust histories, systems, and production contexts that have led to normative assumptions, prejudices, and biases get manifested in algorithmic classification systems, which then go on to reproduce the status quo of systemic oppression and privilege, while simultaneously discouraging alternative explorations of the future. The application of technological fixes to social problems refers to an industry standard that is especially prevalent among young tech startups of the Silicon Valleys of the world, but also within the tech industry at large, that deals with the effects of problems rather than with their causes, and tends to reframe social struggles as engineering problems. To break out of these habits and to counter these dynamics that shape the development of contemporary algorithmic systems, I am introducing the Compendium of Socio-Technical Practices for Algorithmic System Design. This compendium consists of theoretical concepts and practical measures that are rooted in social science scholarship, and its primary goal is to promote knowledge mobilization between disciplines and to support the design of algorithmic systems that result in more equitable outcomes. But before I talk about the compendium in more detail, I need to make one thing very clear. This compendium is not an intervention that pretends to be another silver bullet that will solve all our problems. But what this compendium is an example for how insights and expertise developed in one field can be made accessible for another domain. It is primarily, but not exclusively, aimed at computer scientists, engineers, HCI researchers, algorithmic system designers, and scholars that seek a grounding in this space, and it is a source of reference for interdisciplinary socio-technical research practices that help to gain a better understanding of the impact that the implementation of algorithmic systems have on individuals' lives and their surroundings. Therefore, the purpose of the compendium is to address a few questions. How can we create connections between erroneously perceived standalone domains, initiate the transfer of knowledge and skills between them, and enrich collaborative research practices? How can we foster a multifaceted understanding of a problem space? And what kind of methods could help to promote interdisciplinary work? The compendium is structured into 4 sections, and I'll briefly explain what each of them does. The first section outlines how social science scholarship can be used to reframe algorithmic system design as a cultural phenomenon, why it is beneficial to do so, and how this can inform a more inclusive and non-discriminatory approach to algorithmic system development. For example, I lay out how concepts of feminist thought, as situated knowledge and standpoint theory, critical race studies, or social constructivism are all very helpful for prompting designers and developers to shift their perspectives and to think about the bigger social, cultural, historical, political, and environmental contexts in which a specific technology is introduced. The second section lists practical measures that can be directly adopted by researchers, designers, and scientists as methods for algorithmic system development and as tools for scholarship. For example, among other things, this section introduces readers to guiding gut check questions, a workshop framework, ethnographic approaches, and specific type of analysis. The third section offers suggestions for rhetoric changes that enable a smoother communication between disciplines and promote knowledge mobilization. The fourth section lists potential conference venues and journals that support the dissemination and promotion of socio-technical interdisciplinary work. The compendium is of course not exhaustive. I envision it as a living document, in fact, that expands and evolves over time. And it comes with an open invitation for other scholars, researchers, and practitioners to add more approaches, methods, venues, and categories that reflect the growing body of knowledge about socio-technical algorithmic system design. The key takeaway is this. There's an entire trove of applicable knowledge produced by the social sciences that can make algorithmic system design more equitable and just. And this paper and this compendium are an effort to make this knowledge accessible. Thank you.